Good morning. So in this class we are discussing about the DT-based general steps in finite element analysis. As we know that these steps are essential while doing the any complex or analysis purpose. As we know that there is a 10 steps we have to basically apply for analyzing the any component for we are using for example in FEA going for the analysis there are two methods are there. One is the APT analysis method, then workbench. So if you are carrying the workbench method, that will be effective if you are applying 10 steps. The students will explain you how they apply 10 steps for the component. Okay.
So let me introduce the basics of FEA. So FEA is also called as finite element analysis. It's a powerful numerical technique used in engineering to predict how a component or a structure behaves under real life conditions like forces, pressure, heat, and vibrations. It helps engineers evaluate performance, safety, reliability before actual manufacture. The first step in the FEA is problem definition. In this stage, the physical problem is clearly understood by identifying the geometry, material properties, types of analysis required, such as structural, thermal, or dynamic, and the expected outcomes. Next is pre-processing, which involves creating 3D or 2D models of the component. The model is then divided into small elements through a process called meshing. Proper meshing is crucial because it directly affects the accuracy and computational efficiency of the analysis. The third step is applying boundary conditions and tools. Loads. Here, constraints such as fixed support along with external forces, pressures, or temperature are allowed to simulate real operating conditions. After this, the solution phase is carried out where the software solves complex mathematical equations for each element to obtain results such as stress, strain, deformation, and temperature distribution. Finally, post-processing is performed to interpret, visualize the results using graphs, contour plots, and animations. Engineers analyze these results to validate the design and make necessary improvements.
Let me say about the second step. The next step is discretization, commonly called as meshing. Here, the continuous body is divided into a number of small finite elements which are connected by nodes. Meshing helps in converting a complex geometry into a form that can be solved mathematically. A finer mesh is usually applied in regions where higher stress or variation is expected to improve accuracy of results.
So the third step is element selection, material properties and boundary conditions. After meshing, suitable element types are selected based on the problem. These may be one-dimensional, two-dimensional or three-dimensional elements. Then material properties such as Young's modulus and Poisson's ratio are assigned to the elements. Next, boundary conditions are applied which include constraints and external loads to represent real operating conditions.
The fourth step is element formulation and assembly. In this step, the mathematical equations are formulated for each element analysis. For these equations, element stiffness matrix and force vectors are developed. All the individual elements matrix are the assembly together to form a global stiffness matrix, which represents the behavior of the entire structure. And the last step is a solution post-processing and validation. After assembly, the global system of equations is solved to obtain nodal displacements. Using these displacements, post-processing is carried out to calculate stress, strain, and deformation. The results are usually displayed in the form of contour plots and graphs. Finally, the results are validated by comparing them with analytical or experimental results to ensure accuracy and reliability.
So these are the general steps we are carrying when we are going for the analysis purpose. So these are the simple steps we have to apply in any components like a job, uniform or non-uniform, or one dimensional or two dimensional, three dimensional, so whatever you have taken element, these are the common steps we are applying for the analyzing purpose. Yes, thank you.
Thank you.